Hi, this is a bit weird because I'm in the class, but I'm trying something new. What I want to do is teach you very quickly the power of regular expressions, which is quite technically complicated, so I think by providing a video, it's going to help complement what we do in lecture. So regular expressions are very sophisticated search terms, and they really help us when we're doing text analysis as historians. We can do regular expressions in a number of different platforms. Those of you in computer science may have encountered them in command line applications or some of the programming languages you've been exposed to. And if you're looking for a program and you work with Windows, Notepad++ is a great program. Or on a Mac, you can use a program called Text Wrangler, which you see in front of you here. Let's show you some of the basics of how we can unlock regular expressions. What I want to do is start off by a simple search. Let's look for the word cat. There's a cat, there's a cat, there's a cat, part of catch, there's a cat, there's a cat. Regular expressions let us be a bit more sophisticated. And so the first little tool I want to teach you is that we can do a pipe. We can do cat, we do pipe, and then we type dog, and we search for both. Notice we're getting cat and we're getting dog. I could then do a replacement. I could say I want to replace cats and dogs with the word animal. We do replace all, and we see I own an animal today, although in the past I've owned an animal. Some animals are gray. Let's play Animelch. Drat, that animal is not as much fun as that animal who dug a hole. Okay, so we see the problem there. Simple searches don't differentiate between letters and spaces. So every time cat or dog appears within words, they're going to be replaced with animal in that case. So we can start playing with it in a number of ways. We could start saying we want to find things, only cats that have a space afterwards, or a space before. So here, if I run this replacement, I've put a space before cat and a space after dog, and I run a replace all. It works in some cases, but it still gets screwed up. And that's because monkeying with spaces isn't always a good idea. This is where regular expressions come in. And this is really cool. So let's take cat again. But let's use a special character. And we can use these special characters because down here you see this grep. That's a Unix command line, a command to use. But it also lets us use better search strings. And so we can do \b and \b. Now that \b, we're not actually looking for a \b. That's sort of computer speak for a word, for a break, the beginning of a word. And so if I start searching now, and I replace with animal, it doesn't get catch. It just does these. And because we can begin to stack these, there's cat. Let's also look for dog. We replace all. Finally, it's starting to work. There's some other commands that we can use. And again, I'm not expecting you to remember all these, because we're going to talk about them in lecture as well. But if we wanted to look for gray and gray, we can use this. And if we wanted to find phrases, we can use parentheses. It's kind of like algebra. So we could do this. We're looking for gray and gray. Again, we find it. Or we could say we want to find these phrases in brackets. Very cool. We can also use keywords and wildcards. So for example, if we look for this, D.G, we're going to find Doug, we're going to find dog. And we could also do different things like that dog, doog, doog. And if we do a search and we type in D-O plus G, that plus can be anything. And so here, look. Very, very useful when you're looking for stuff. And of course, we can combine all of this. The last things I'll show is just one final command. And that's if we went, say we wanted to say, I like dogs and cats. What if we had that all over our document and I wanted to say, I like cats and dogs, not dogs and cats? We can do that pretty easily. And so we say dogs and cats. Notice the space there. I do it backwards. I get dogs and cats. Now that is actually group 1, group 2, and group 3. And that's a bit confusing, so let's just put it this way. When I type \3, that's actually referring to cats. 1, 2, 3. \2, that's and. \1, that's dogs. I press replace. Boom's changed to cats and dogs. So this is pretty cool. But you're probably not sold on why it is useful for historians. And so I want to actually show you right now how a historian can use regular expressions to do something really neat. And what I want to do is show you how we could use it to clean up information that we found on the Internet Archive. Here we have the diplomatic correspondence of the Republic of Texas. Letters from officials to other officials and around the world. And of course we see that's a bit messy. I'll show you how we can clean that up as well. And as we scroll down, we see we've got a lot of letters. We can actually make a network diagram out of this. So the first step I would do would be to copy all of this out to all of these letters to a text wrangler. So we can manually do this. It's a bit painstaking. Copy, new, and paste. That's a lot of information. Now what we actually want to do, so notice it's like Sam Houston to J. Pinckney Henderson, December 31, 1838, on page 51. What we actually want this to look like, if we want to make a network diagram, which I'm happy to talk about with people, would be something like this. We want to make it look like this. The sender, the receiver, the date. So I want to show you how we can do that. So what we want to first do is find all the lines that have a letter. And a quick way I might see looking at this is that if a letter has 2, that means it's a line we want. So that line has a 2. Digitized by Google 8 Contents doesn't. So we want to get rid of those lines. So let's use one of our regular expression lessons. Let's go back to our cat example, but instead of cat we're going to use 2. So break, 2, and I start searching. It's just going to find 2s. It's not going to find tomorrows, it's not going to find lines with Google, etc. And because we know earlier that if we did that dot, which is a wildcard, any character, and we do plus, that's going to find any number of characters before 2. And then we do any number of characters after 2. And if I start finding it, notice it's flagging entire lines that have that correspondence. And if we put it in brackets, we make that into group 1. Remember the group 1, 2, 3? We do backslash. And we're just going to put a tilde in front of those lines, some sort of character that we're not going to have, so we can start to get rid of things. So I do a replace all, and suddenly, every line that I think is a letter has a tilde in front of it. Our next step is we want to get rid of those tildes. So to find all lines that don't have a tilde is to do this. I want to find new lines. It's a new command I'm introducing, \n, searches for a new line. And so we're saying, I want you to look at the start of every new line. And I want you to find everything that isn't the following. And the isn't is start of line, tilde, and everything after it. We have to get the enter in front, so we had a carriage return. And I'm going to replace this with nothing. I know this is a bit of Greek. Replace all, and suddenly all those lines that didn't have 2 are gone. Now we want to get rid of our break lines, so we use new line and carriage return, which are just blankness. We replace all with nothing. It screws up. Never do this live. And so I actually remember that what happens is that different computer systems have different ways they've encoded text. And so on Mac, we're using something a little bit differently, which is just a simple carriage return instead of new lines. The differences between Mac and Windows are going to vex you. So if you were following along with Windows and you did the first one, it probably worked. Since we're on Mac, we're going to do this one, and I do a replacement, and boom, those lines are gone. So now that we've gotten rid of those extra lines, it's time to format the text document into what we wanted before. Because we want to have that simple setup where we've got first name, comma, second name, comma, date. And so we need to start sorting it. So first of all, let's find, we want to remove the page number after the year, and we want to remove this comma. And so the easiest thing to do is to find a 4-digit number. And so here we type in 0 to 9, which is any number between 0 and 9. And here we say, I want 4 things together. So basically, find every incidence of 4 digits together. That's years. And now I'm going to say, I want to get everything after that. And then I'm going to make those little parentheses that make those different groups. So we do that comma. We open up a second group. We open up a third group. So again, group 1 is that comma. Group 2, group 1 is this comma. Group 2 is that for numbers, and group 3 is everything after it. And I just want to replace it with group 2. And if I press replace all, suddenly it's clearing it all out. Now it's looking good. Let's get rid of those tildes. This is pretty simple. Find all those things, replace it with nothing. They're gone. Let's get rid of that 2. And so here, we've got a space and then the word 2. And so what I do is 2, space, 2, line break, replace with a comma, replace. Now we've got some lines that still aren't perfect. It's looking pretty good, but some of them have some junk data, some of them look pretty messy, etc. Sometimes we're seeing messy stuff, but other times we're seeing things that shouldn't be there, such as copy and summary of instructions, United States Department of State. That's useless. We want to get rid of some stuff like this. But our fear is really the ones that have too many commas, like here. Too many commas, that's actually going to throw stuff up because we want to put this into Excel and get one column here, one column here, one column here, separated all by commas. Here we're going to get 1, 2, 1 column, 2 column, 3 column, 4 column. It's going to screw everything up. So basically, we're just going to start to look for any line that has more than 3 columns. So anything, comma, anything, comma, anything, comma. This will actually show us any line that has more than 2 commas because it's going to find any line that has a set of characters, then a comma, then another set, then a comma, then another set, then another comma. And yes, if we start going around here, we're seeing our junky little lines. Now there's not too many of them, so what we need to do actually in this case is to just mark it up by hand. So we actually know in that case who it's from. Here we might make a decision, August 2, 1844. Kind of painstaking work, but it's important. So we're seeing here we're actually cleaning up OCR errors. And we go on, this takes about 2 minutes, 3 more minutes to do, but we'll just leave it there. And as we search, we find other things that are messy. Then we save it. I'm going to say it as clean correspondence, CSV. It's not perfect because, again, I should have cleaned everything up. But I load it up and suddenly we have a really good spreadsheet that actually has roughly what we're looking for. Sender, receiver, and date. Now, there is a program that we can use to fix this stuff, and it's something called Open Refine, which I've just shown you here. I don't think we're going to go through that in today's class, but I'm providing a Word document for you that you can use to clean this stuff up. And so what that would do would find, it searches and it would actually find that maybe this means, you know, who's the common LaBranche. It would help to clean that up. And if something was misspelled, such as January was misspelled because of an OCR error, you know, Janu-Ferry, it will find those things by looking at very narrow differences between the two. Very, very important and useful piece of software to make all those values line up. And if you have any questions about that, happy to help you. And again, up on Learn, if you do this for your final project, you've got that posted. But let's just really quickly show you how we can make a quick graph out of this. So I go to Excel. I add a row, and I take source, target, date. I'm going to save it as Texas. Oh, it's just, we'll keep it at clean correspondence for now. Let me load up a program called Gephi. Which I use for a lot of my work. And I'm just really quickly, I'm going to start a new project. I'm going to import this spreadsheet. Separator, comma, source, target, date. Has an edges table. I'm just going to take the source and the target for now. And here we are. This is a visualization of the correspondence of the Republic of Texas. And once we're in Gephi, we can add labels. We can do all sorts of amazing things that I'm happy to show anybody, or we may be able to talk about in a few weeks' time, because it's one of my favorite programs to use. For example, we can find the different communities. We can start to make it look pretty. and we can even start to generate very interesting visualizations to find out about the structure of this relationship. But that will have to wait for another day.